Alright, if you're watching this video tutorial, you likely have an interest in how the fish passage at the lock and dam site is expected to impact river levels and shoreline in the Augusta area. As a reminder, the fish passage is part of the Savannah Harbor expansion project in Savannah. And I think you'll find out this tool is pretty easy to use, but before we get started I want to make a few points about how the modeling and the illustration works. Users will notice if you kind of zoom in and take a closer look at the shoreline that the model's existing conditions line illustration for the shoreline may not exactly match the actual shoreline as shown in the Google image in every place. And I've kind of zoomed into one area that's an example of this. And there's several reasons why this may not be a perfect match, and I won't go over all of them, but I'll go over some of the common ones. And the first one is that the model is showing these shoreline conditions based on a lower average flow of 5,000 cubic feet per second. And most of the time the river is flowing at higher rates than that, probably closer to 8,000 cubic feet per second. And that's probably what we're looking at here in the Google image as compared to the model's illustration. But the second reason is if we zoom in a little bit closer, you'll notice that the satellites are hitting this image at about a 75-degree angle, and you can tell by, for example, looking at these buildings, you can see the facades on the side here. And if we were looking down at a perpendicular angle, we'd only see the rooftops. Well, the model illustration lines are based on looking at this map at a perpendicular angle, and so when we overlay the model's lines over this angled image, it can also be skewed a little bit there. And there's a few other reasons here, and you can see them in the show disclaimer, but I think you get the point. So using this tool is pretty easy. If you've used Google Maps before, you can zoom in and out, you can click and drag, and we've got these yellow dots here that represent points in the river, and each one of these represent a dock. You can click on one of these yellow dots and you can get a profile window. What shows up here is like a street view window of the dock, and then it gives you a key of all of the existing conditions here, that depth, and then according to our models, how the other alternatives and the different fish passages would impact or projected to impact the depth of this particular location. So you can see existing conditions 5,000 cubic feet per second. This dock is at 13-foot depth of water. At the recommended alternative, you can see it's about 11.2, so a little less than a 2-foot impact there. Also, you can just turn on the other shorelines just to kind of take a look at the shoreline and see how these shorelines are compared to the existing conditions. And I'll just go ahead and leave the recommended shoreline up so you can kind of see an example here. You can click on the shoreline there too, and it'll tell you this is Fixed Weir with a floodplain bench. You can also roll over on this key here to get a pop-up window there that shows that this is the Fixed Weir with a floodplain bench, and this is the recommended plan. Something else that's useful is if you know your address and you just want to go quickly to that one spot without clicking and zooming, you can click on this brown box here, and you'll get a list of addresses, and you can just select the address of choice, and the tool will take you right to that point. You can center the profile window, you'll see the street view sign, and then again the depth comparisons here. And if you just want to see the shoreline, you can kind of close that out there and take a look at the shoreline. One thing that's important to keep in mind here, though, is that this tool will help the user understand the relative differences between each alternative and the existing conditions at the lower river flow of 5,000 cubic feet per second. As you can see, the shoreline here is one of those areas that doesn't precisely match up. But what matters is the difference between the model's existing conditions and the alternative that you have selected here showing. So these relative differences are more accurate than the absolute location of the line compared to the aerial image. So I hope this video is useful to you, and give us a call if you have any questions. Thanks.